Networks do not stay the same for long. New applications are deployed, connectivity requirements evolve, performance tuning is requested, and security rules must adapt to emerging threats. In this episode, we focus on controlling network changes safely, because even well-intentioned updates can introduce outages, vulnerabilities, or unintended exposure if they are not managed carefully. Baselines, structured approvals, and disciplined rollback practices create guardrails that allow change without chaos. Safe change control is not about slowing progress. It is about making progress predictable and secure. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A baseline is the documented, approved configuration state of a device or system. It defines how routers, switches, firewalls, and other components should be configured under normal conditions. Baselines provide a reference point that teams can compare against when evaluating proposed changes. Without a baseline, it becomes difficult to determine whether a modification is safe or whether it introduces unnecessary risk. Baselines create clarity by defining what good looks like. Establishing a baseline requires collaboration among network engineers, security professionals, and operational stakeholders. The baseline should reflect functional requirements as well as security controls. For example, firewall rules should align with approved access policies, and routing configurations should reflect intentional connectivity paths. Documenting these standards prevents drift and ensures consistency across devices. Over time, baselines reduce configuration variability that can complicate troubleshooting and security review. Change approvals introduce structured evaluation before modifications occur. Instead of allowing ad hoc adjustments, teams submit change requests that describe the purpose, scope, and potential impact of proposed updates. Reviewing these requests allows peers or managers to identify risks that may not be obvious to the original requester. Structured approvals reduce the likelihood of accidental misconfiguration or unintended exposure. Thoughtful review strengthens accountability and awareness. Approvals should balance thoroughness with efficiency. Excessively complex approval processes can slow necessary improvements and encourage workarounds. At the same time, superficial reviews may miss critical risks. Effective change control establishes clear criteria for evaluation, including risk assessment, rollback planning, and communication plans. Transparency and clarity improve compliance with the process. Testing proposed changes before full deployment reduces uncertainty. Whenever possible, changes should be validated in controlled environments that replicate production conditions. Testing confirms that new configurations behave as expected and do not disrupt services. Identifying issues during testing prevents broader impact after deployment. Pre-deployment validation supports confidence and reliability. Rollback discipline is equally important because not all changes succeed as planned. A rollback plan outlines how to restore the previous configuration if unexpected issues arise. This includes preserving backups of existing settings and documenting recovery steps. Rollback planning demonstrates foresight and responsibility. Knowing that recovery is possible encourages careful but confident change implementation. Timing also influences change safety. Scheduling updates during planned maintenance windows minimizes disruption. Coordinating with affected teams ensures readiness and awareness. Clear communication before and after changes prevents confusion and supports transparency. Timing discipline reduces operational friction and maintains trust. Monitoring after changes is essential to confirm success. Observing system performance, connectivity, and security logs verifies that the new configuration functions as intended. Early detection of anomalies allows quick corrective action. Post-change validation closes the loop between planning and execution. Monitoring reinforces accountability and stability. Configuration management tools can assist in enforcing baselines and tracking changes. Automated comparisons between running configurations and approved baselines highlight deviations. Alerts triggered by unauthorized modifications provide early warning of potential tampering or error. Automation enhances consistency, but should be overseen by knowledgeable personnel. Human review ensures context-aware decision-making. Documentation supports long-term effectiveness of change control. Recording what was changed, why it was changed, who approved it, and when it was implemented creates an audit trail. This documentation assists future troubleshooting and compliance reviews. Institutional memory strengthens organizational resilience. Clear records reduce reliance on individual recollection. Cultural factors influence the success of safe change practices. Teams must value discipline and resist shortcuts. Encouraging open discussion of proposed changes fosters shared responsibility. A culture that prioritizes reliability and security strengthens adherence to structured processes. Collaboration builds trust and reduces conflict. Emergency changes present unique challenges. In urgent situations, rapid action may be required to address vulnerabilities or outages. Even in emergencies, minimal documentation and post-event review should occur. After-action analysis identifies lessons and reinforces process improvements. Balancing urgency with discipline protects stability. Cloud networking introduces additional considerations, as configurations may be modified through automated scripts or infrastructure as code approaches. Change control practices should extend to these environments, including version control and peer review. Automation can enhance consistency but requires oversight. Applying baseline and rollback principles consistently across environments maintains unified governance. Ultimately, controlling network changes safely ensures that evolution does not become instability. Baselines define trusted states, approvals introduce thoughtful evaluation, and rollback disciplines safeguards recovery. Together, these practices reduce unintended exposure and service disruption. Over time, structured change control builds confidence that network infrastructure can adapt securely and reliably. Safe change management transforms necessary evolution into a controlled and resilient process.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.